please. So welcome to day 2 of our Nitrate Treatment Technology Workshop, co-sponsored by the State Water Board and CDPH. This has been a really good collaborative effort. We've been meeting for a number of months trying to pull together speakers and your program for these past 2 days. And hopefully you're finding the presentations informative. We're just wanting to show you various options that are out there, some of the obstacles, some of the issues for some of the disadvantaged communities, and start some dialogue. So, recapping. First of all, in case of an emergency, please exit, go down the stairs and out to the park. The restrooms are to the left, and we will take breaks, and I encourage you to network with other people outside the room, in the lobby, and my job is to try and get you out of here on time, but with all your questions answered. So, yesterday, we had a very full day. I forgot to say, my name is Geeta Kapai. I'm the Director of Public Participation for the State Water Board, and I'll be facilitating the day today. Yesterday, we heard from a number of people on topics such as the effect of nitrate on groundwater, the regulatory requirements and health concerns regarding nitrates, impacts to small disadvantaged communities, some of the challenges of treatment of nitrates, followed by disposal options for the residuals from treatment systems, and a general overview of biological treatment. And that was just the morning. The afternoon brought presentations on various biological treatment technologies, including smart water systems, MicroV Biotech, Aeronite, Envirogen, utilizing a fluidized bed bioreactor, the Biota system, and some insights from demonstration studies. Today we'll be hearing about other challenges facing small systems, the certification of point-of-use devices, experiences from some small disadvantaged communities, and we'll hear about some other treatment technologies. At the back of the room, there are speaker cards. Yesterday, most people didn't use them. We'll just pass along the microphone. If you want to fill out a card, that's fine. For those of you on the web, the web address is auditorium@calipa.ca.gov. If you'll send your comments to that email address, we will read them out. I will take comments from the audience in the room, then I'll take those on the web, and then if there are any others, I'll take those as well. We do have strict time frames here. We have a very full agenda. So for speakers, I ask that you limit your presentations to 20 minutes, so we allow 5 minutes for any questions that may come up. I believe we have some panel discussions today, so hopefully we'll answer any questions you might have. And I just want to say too that, this is a co-sponsored workshop. We're not endorsing any special technology. We know there's a problem out there, and we're working on various options to try and solve our drinking water problems. So with that, we'll start with Cindy Forbes from CDPH. Hang on, I'm coming to you.
I know yesterday you gave a website that they could get the full, yes. So maybe you could give that one more time.
That again. So once again, for those of you on the web, all of the presentations that are being shown today and from yesterday can be found on www.drinc, and then I need the rest of it, .ca.gov/DNN. Once again, drinc.ca.gov/DNN. Thank you. Oh. One more thing.
We're recording this?
Oh, yes. Okay, we are recording this. The video, audio presentation will be available after the workshop. We will try and find out what that address is and post that. And for those of you that are speaking, if you ask a question, please identify yourself and use a microphone so that those on the web can hear us. Thank you.
Now you can talk. I was just saying, now that I know that I'm being recorded, I'm going to have to behave myself while I'm up here. Certainly will change my normal strategy for giving a presentation anyway. Good morning. My name is Cindy Forbes. I'm the Southern California Branch Chief with the Drinking Water Program of CDPH. I guess my goal this morning is to tee up for you the challenges that we see when dealing with small water systems and overall trying to enforce the drinking water standards across the board equivalently on both the large water systems and the small water systems. My area that I oversee is from Stockton on the north to the Mexican border. I oversee 13 district offices, so we see the largest water systems in the world down in Southern California with Metropolitan Water District of Southern California and Los Angeles Department of Water and Power. And equally, we see some of the smallest water systems. And I'll give you a share of the variety of what my staff deal with in the field. Teeing up what the universe of public water systems looks like. And I understand that there are a lot of folks in here whose issues go down to the individual private well. But when you talk about what the federal government requires us to keep into compliance with Safe Drinking Water Act, this is what our universe looks like. In the way of community water systems, there are roughly 3,000 of them within the state of California. We have one of the largest number of community water systems in the United States. But of that 3,000, only 700 of them serve more than 3,300 people, or greater than 1,000 service connections, and meet our large water system definition. So that means less than a quarter of the systems that we have to bring safe water to are really of a size that it makes it economical for them to do so. So these small water systems are from 15 service connections on up. As you heard yesterday, there are lots of concerns over smaller systems even yet than that. Likewise, we have non-community water systems. Those are the restaurant you stop at on the way to Yosemite or any place that serves the public that has their own water supply. Those also have minimum standards that have to be met to ensure that when people stop there, they're not going to get sick because of it. Then the non-transient, non-community water systems, those are typically places of employment or schools where people don't live there. There's not a living quarter or dwelling, but they're used every day or at least more than 6 months in a year. So this is the way it shakes out. So statewide, we have about 7,500 public water systems that we deal with. This slide, I kind of wanted to just present the numbers. By the numbers, those 700 community water systems serve about 37 million people within this state. And that represents about 98% of the total population. Those small water systems that we talked about, the ones that have less than 1,000 service connections, they only serve about 400,000 people and about 1% of the population. The other 1% that's not accounted for are typically folks that are living with a private well. So they've, a farmhouse with a well. They are not considered a public system. The other reason these two pictures are up here, I was trying to highlight the difference between what a typical large water system's well might look like. It would be constructed with a huge pedestal to prevent any kind of flooding and has all the appurtenances that are specified in our California Waterworks standards. The well on the right is a typical example of what a well for a small water system might look like. Now there's challenges for these small water systems. As you heard yesterday, when you have a water quality violation, it's expensive and difficult to achieve compliance. And the United States Environmental Protection Agency recognized that this isn't a problem that's specific to California. This happens across the United States where state drinking water programs were challenged by the difficulty in bringing these smaller systems into compliance. So in the Safe Drinking Water Act amendments of 1996, they included requirements for what's called capacity development. Now in the olden days, and I've been around for a while, in the olden days when we talked about capacity of a water system, it meant how much water did they have available to serve their customers. That no longer is what capacity means. It now means their technical, managerial, and financial capacity. And again, these are photos of typical small water system facilities that we deal with when we go out in the field. Now, when we start talking about the technical challenges that small water systems face, we're talking about lots of times they don't even have a meter on their sources. So they lack the basic information as to how much water is used within the water system. The distribution systems are often old and leaking. Most of these systems were installed after World War II, when the baby boomers were all growing up and being part of this population. And so these water systems proliferated in the 50s or before. And so much of that infrastructure has been in the ground for 60 years. And it's in need of some serious replacement. They don't have engineering support, and they don't have ability to assess what they need to do to return to compliance when they have an issue. And usually when they have a problem and they have to do something, the solution that they need to implement has some environmental concerns. So there's permitting and dealing with other agencies besides just the CDPH drinking water staff. And again, on this slide are photos of some typical storage facilities that we see. They're typically not maintained properly, leaking water lines, and in need of some major enhancement. Additionally, they have managerial challenges. In most of the small water systems, the person who runs the system either is the person who's married to whoever is the secretary and collects all the money, or it's somebody who took an interest in it when they retired from whatever their real job was in life. Or it could be the custodian at the school, or the dog catcher also has responsibilities to oversee the water system. Oftentimes, these small water systems, they don't even know if they own the plot of land that the well is drilled on. So there are ownership problems that we deal with. There's usually lack of water rights information. They don't have the proper paperwork to demonstrate that they own the water that they're using. And again, the operator is usually somebody who got the short straw to be out there doing shutoffs and turn-ons based on payment of water bills. Now, this is obviously the biggest challenge, and it's the financial challenge. And typically, in small water systems, before the new plethora of water standards that cause them grief, like arsenic, and some of the newer ones that cause them to provide treatment, in the olden days, they would get the electrical bill for operating their wells divided up by the number of people that were there. They paid the person who was doing shutoffs a little bit of money, and they had to take like one bacteriological sample a month, and once every 3 years they did their chemical monitoring. So their rate structure was like so low that people didn't complain, and they paid their fair share. If the pump went out, they passed the hat, people kicked in, they replaced the pump. The problem is they've deferred maintenance, they don't have any reserves, and long term, they haven't set themselves up to be able to replace any of the infrastructure that they currently have, and now they have a water quality problem that has to be solved. At the end of this process, they will end up with water rates that are or will be too high for most of the residents to be able to afford, especially if they're on a fixed income. So treatment, while it can solve some of these water quality problems, it's like piling on costs to residents that are at the margins of being able to afford what they currently have. And additionally, when we have a privately owned water system, like a mobile home park, they aren't eligible for any grants. So they have to borrow the capital to put the infrastructure in. So that is also another real complicating challenge. So I've kind of teed up the challenges and how we get there, but when we're trying to solve the water system's problems, we have to be able to find a solution that community can afford the operation and maintenance. And yesterday afternoon, we heard a lot about new possible treatment technologies for removal of nitrates. And we have large water systems that spend a good deal of time, money, and in evaluating which approach they're going to take to minimize the impact on their huge customer rate base. But it means more costs, and you have to have an operator that's capable of running those treatment facilities. We've come a long way from having a chlorination vat and the person's responsible for making sure the pump kicks out the exact correct dosage of chlorine. It's a little bit, with some of these new technologies, like taking somebody who has a license to fly a Cessna and putting them in the space shuttle. It's not a good fit. So as this treatment gets more difficult, you need greater operator expertise to run these treatment systems. So as the treatment needs increase, so do the operation and maintenance costs. And right now, even if our funding is used to put the capital in to solve the problem, the water system is responsible for the operation and maintenance costs. There is no way to defer those costs by use of any governmental funding. So as we look down the line, these small water systems, when we solve their first water quality problem, we sure have to hope that a second contaminant doesn't come along that will require additional treatment. And that's one of the other big issues is if you put in treatment for nitrates, typically it's not going to help you with Chrome 6 or 1,2,3-TCP or an organic contaminant. So you need layers of treatment with all the layers of O&M costs. And I think I covered the rest of that. So I'm going to pull out my soapbox just for a little bit because you guys let me up here and go down the path of how do we prevent water quality problems. We have some excellent well construction standards that are used for all new facilities here in the state of California. And the waterworks standards have some minimum sealing requirements when you drill a public water supply well. Now, why is she bringing this up? Because those requirements do not apply to a private well. And so some of this old infrastructure that's out there maybe have seals that are less than 20 feet deep. And the problem is nitrate is a contaminant that starts at the surface. And if you have nitrates in your well, my problem is what else is that well picking up? Because you're able to get anything that's used on the surface. So nitrates in my book is just a little bit of an indicator of what else could be wrong with that water supply source. So in areas where we have high nitrates, what we typically see are the large systems are doing some really creative engineering of test wells with select strata sampling to see if they can identify low nitrate sources. And the best way to move forward remains serving water that meets the standards without treatment, because treatment adds on O&M costs and operator costs. Now, most of these small water systems, as I indicated earlier, have wells that preceded many of these safeguards that are now in place to help them assure that they have water that meets the standards. So when we have small water systems that now become non-compliant, the first thing we start doing is looking around, are there any large water systems in the area? Are they close enough to connect? And if they aren't, what did that large water system do if it had the exact same water quality problem? Because we piggyback on what the large water systems do. They typically find the best solution that we then try to offer or suggest to the small water systems. So if the large water systems are drilling deeper wells and putting good seals in, and that results in water that meets the standards, we're going to suggest that approach rather than treatment, because we try to avoid treatment at all costs. Now, yesterday afternoon, we heard about these approaches to solving a nitrate problem: reverse osmosis, ion exchange, blending. While it isn't scientific, it isn't creative, it still is the cheapest treatment solution. And when you have a source that has low nitrates and you can blend that with a high nitrate source and get below the standard, that is the most affordable solution for that community. Again, all yesterday afternoon, we talked about this new wave of technology which uses biological treatment. The best thing about biological treatment is that it eliminates the need to deal with these brine wastes. And when you are inland, meaning in the Central Valley, as you heard from the regional board yesterday, there's no magic bullet way to dispose of the brine waste, and that becomes the deal killer. Because even if you can afford the treatment, you have additional costs to deal with the residual waste. So, which leads me to, I sound like a broken record, but consolidations, when we can secure them, are the best solution for a small water system that cannot meet drinking water standards. And we beg, borrow, and steal with the large water systems, attempting to get them to interconnect some of these small systems that are in close proximity to their boundaries. When we get that interconnection, all of a sudden, the rate base for partitioning out O&M costs just gets a little bit bigger. It gets bigger for the large water system too. They secure additional ratepayers. It solves the TMF issues permanently for the small water system. They will never again be considered a capacity problem. Now, the large water systems, they bring to the table more resources to evaluate the needed treatment and opportunities to get creative in constructing wells that will meet the standards. Because of this, we've recently modified our intended use plan for use of our state revolving fund monies to have incentives to encourage the large water systems to run a line out to the small water system. We will fund an improvement that large water system wants to get them to take on the small water system. Now, it's not going to work everywhere. There are isolated small water systems, and those are going to remain challenges for us to bring back into compliance with the drinking water standards. But as we move forward with this new incentives approach, I can guarantee there are a lot of large water system personnel in this audience right now, and you're going to hear from my staff in the future where we are begging you to take on a small water system challenge that we have. Now, what are the obstacles? Why do the large water systems not want to do it? And I'm just going to be candid. The first thing they say is, what's in it for us? This is a problem that you want us to take off your hands. And we admit that it's a problem. Lots of times, these small water systems have distribution systems that are undersized and leaking. They don't have meters, and they don't have a lot of assets. In fact, they usually are a liability. And so the large water systems are not really interested in taking these guys on. In some cases, we have some crazy laws in this state that says if a large water system extends its boundary, they jeopardize what's considered their charter city status. And that alone has been the excuse to not take on a small water system that's just on the outskirts of town. So we need to get creative in our planning efforts and in how we move forward to ensure that small water systems that are on the outskirts of town, that they have the opportunity to connect to the large system when and if a new water line is running by. And it should be part of the planning. I call it green mail, you can call it black mail, but we need to make sure that some efforts are made to pick up these little guys so they are not left out there struggling, trying to remain in compliance for the rest of their lives. Now, one of the big issues, and I'm being candid, a lot of those small water systems, why are they out there and operating individually in an isolated manner? Because when they first wanted to develop whatever the heck they put in, they went to the large water system, and the large water system said, these are our specifications, and you have to put in this size pipe and do this and do this and do this. And the subdivider said, screw that, I'm not going to do it. I'm going to go put in my own little isolated system. I can save a whole lot of money. So they put in a 2-bit water system and sold all the lots and went away. And who got screwed? The people who bought those homes. So there usually is some history between the large water system and the small water system because they're annoyed that they didn't connect in the first place. So that becomes a huge challenge to get past some of those historical differences to get the interconnection. So we are struggling and working to have some of those barriers broken down, but it is not easy plowing in that arena. Lastly, for whatever reason, you have some small water systems who crazily think that there is something in it for them to remain an independent entity. They own it, they control it, and they think that that brings them, I don't know, some sort of world peace, but they are not in the real world. They need to get out of the business. I have yet to see a small water system that makes any money or has anything that could even be widely conceived as an asset. So what are some other solutions? If we put on our thinking cap, I'm sure legislatively, probably not supposed to say this, but every large water system should have to interconnect people that are around their boundaries. I've been saying that for years. If that was a requirement, they had to throw out a net a mile long. If you touch a small water system, tag, you're it, you have to interconnect them. But there has to be some incentives. It's not a free ride for the small water system. And if we could get creative about how to do that, we would tackle many of these 2,500 small water systems that are out there that people live in and they can't get adequate drinking water. From a planning perspective, when new development is proposed and it's going to be out somewhere that's not contiguous, we either have to make the hurdle to put that in so high with the TMF requirements on that system, or we have to have them be forced to interconnect any small water system that they're near, so that that rate base for both systems gets larger and we have some system reliability. We have IRWIMP, Integrated Regional Water Management Planning, that is focused on providing reliability, helping various regions deal with climate change and other kinds of things outside their control that impact their water supply portfolio. And I think we need to be creative and start tag teaming with some of those efforts and putting some incentives in for helping the small water systems that are sitting out there isolated. That's the world according to Forbes. So before I get off the podium, and I think I've teed this up, there's some challenges out there, and treatment is obviously, in my mind, the last and worst possible way to solve a small water systems problem, because they're going to forevermore be forced with dealing with the O&M cost of the treatment and the operator cost to run the treatment. And it's challenging for the large. So with that, I have a number of staff that are here in the audience, and I'd like to point out that I have Carl Carlucci, who's the regional engineer. Can you just raise your hand, Carl? He has all of Central California, much of the high nitrate area. I have Tricia Wathen and Betsy Litke, who are the district engineers that oversee much of this area. So we're from the government. We really are here to help. And I mean, regardless of what you might think at this point, but we have to tag team, we have to pile on, and we have to try to bring solutions that these communities can afford in the long term. And that's our goal. So thank you. Are there any questions? Wait a minute, Chad.
So I'll be on that same bandwagon of
Name?
So I'm Chad Seidel Jacobs. I'd follow that same bandwagon of throw the mile-long net out. And I know there's a lot of GIS tools that the department's been working on. In fact, boundary area tool, saw some of that detail last week. Has the department done an assessment of how many systems would be within a 1 mile reach of quote-unquote larger systems? I'm just curious how many of those systems that we're talking about trying to help them solve problems in this setting would be captured by that, knowing some that wouldn't.
It's a great question. Thank you for asking it. I have not been involved in the boundary project, but I would love to know that statistic first. I mean, first and foremost, we ought to focus on those. Not saying we're not going to work on the isolated small water systems, but if we could solve that universe of small water systems, it allows us way more time to solve the other problems that are going to remain. So it's a great point and something we really do need to put our best hats on and deal with.
I'm Tim Worley with the California-Nevada section of AWWA, and my question goes back to how some of these problems began, and it seems like the county planning process really should not allow some of those developments to take place when we know that the problems are going to occur down the road. So my question is, how is the department interacting with county planning, with the local agency formation commissions to prevent some of these in the future and hopefully address some of the problems that exist because of bad planning decisions in the past?
Thanks for that question, Tim. Great question, actually. And we talked about that, ironically, in the car on the way to the workshop this morning. And Betsy Litke, who oversees the small water system program in Fresno County, basically said, as these freeways get extended a little bit, what happens right at the end of the freeway? Some brilliant developer owns the land and decides he wants to put in the stop and rob and the quick this and the Chevron. And she said, I'm getting all these CUPs, conditional use permits, for varied facilities at the end of these little things. She says, I'm going to tell the county they have to hook everybody up. You can't have multiple small, and that's what we have to do. We have to just start saying, hell no. Even if they try to meet the financial requirements, it doesn't make any sense, because eventually the Chevron station's water supply pump is going to go out and they're going to be screwed. And if they were interconnected to the AM/PM across the street, then they both wouldn't be out of business. So, I mean, we have to get more forceful and more creative in how we approach some of these new developments. And the financial, I should have mentioned that California was one of the forefront leaders in requiring financial responsibility for new water systems. So what we're really talking about here are the artifacts of what was created before responsible people started saying, this leapfrog development stuff doesn't make any sense and is creating a bunch of nightmares for us.
Terry Schrepfer with Provo and Pritchard Consulting Group. Are there specific legislative changes that you would propose that'll make your life better?
My big boss is sitting in the back of the room, and I think I am precluded from suggesting any kind of legislative changes, but use your best thoughts. I mean, I think we've lined out a couple of them, but there really needs to be a holistic look at what we've got here. And I guess what I would say is PG&E doesn't have this problem because somebody new goes in, they just run the same line. I mean, you don't have the same sort of independent sorts of utilities popping up in either the phone company or PG&E. And if that sort of requirement was the same for water systems, we wouldn't be where we are. I mean, I see some representatives from very large water systems that operate in Southern California, and every water system is almost interconnected. When you get on the south side of the Tehachapi's, they have turnouts and services and emergency connections to all of their neighbors. So we don't run out of water. Well, we're going to run out of water eventually, but we don't have these water supply issues that crop up when the only well is now found to not meet drinking water standards. I mean, gone are the days where you can put in a new subdivision where you have a single source of supply. The waterworks standards now say you cannot put people in a community and only have one well. That's no longer allowed. But we have, I don't know, I can't even begin to tell you how many water systems that are out there that have a single well. And when that thing craps out, you can't flush your toilets, you can't take a shower. It is a public health emergency. Thank you for the opportunity to address this with you, and I look forward to working in the future with solving a lot of these small water system problems. We are going to have to roll up our sleeves in some cases to figure out solutions that'll work for everybody. With that, I'd like to introduce Mark Bartson, who works for our CDPH, and Eugene Long is going to follow me up because he's going to talk about an interim approach, which is point of use treatment. And then Mark's going to talk about introducing the rest of the speakers for today. But thank you for the opportunity to talk with you this morning. Thanks. Sure.
Thank you, Cindy. Good morning. This is Eugene Long with Department of Public Health. I'm the water treatment specialist for the program. And my goal right now is just to, now that you've heard of our problems that we have with drinking water and finding long-term solutions, we're not going to be able to solve it overnight. So it's really important for us to find solutions for communities that may not be the size of a public water system or some of these really small disadvantaged systems for them to solve a nitrate problem in the interim. So point-of-use devices in California is allowed as an interim solution. It's not looked upon as a permanent solution because the use of POU will require a lot of maintenance, and we don't really know how it is actually more complicated for you to roll out a point-of-use device program when you have 50 homes, that you need people to go into their home and maintain these units on an annual basis, and then also collecting samples from these units on a routine basis. So on a big picture, long-term solution, we're looking for centralized treatment. That was probably the best solution, but in the interim, we really need some point-of-use devices so that we can bring safe drinking water to these individual homeowners or these small water system users so that they can have safe water without the need for hauling bottled water or purchasing other water in the interim. So the point-of-use devices in California is regulated in two aspects under the Department of Public Health. The first aspect is we have a water treatment device certification unit. And under that unit, all devices that makes a health claim, so if you have buying point-of-use devices at your favorite home improvement store, when you look at the box, it will say that what are the claims that it claims to reduce, such as nitrate, arsenic, or whatever contaminant that they may be claiming. And when you look at that box, if they say that they can reduce nitrate, for example, that's a health claim. And in order for them to make the health claim, they need to have the devices challenge tested by independent certifiers, which will be our upcoming speakers. There are multiple certifiers out there, and we have invited 2 of them to come talk to us this morning about their certification process. And the second part for the point-of-use devices is under our drinking water program. For public water systems that's greater than 15 service connection and less than 200 service connections, we actually allow them to propose as an interim solution while they find the permanent solution in solving their water quality problem. So for example, for nitrate and arsenic, they can use a point of use while they're devising a solution. Maybe they're doing pilot testing or determining whether they can extend the water main from a nearby water system to solve the problem, but we need something now. So the point of use is our stopgap interim solution. So with that, I'm going to turn it over to my supervisor, Mark Bartson.
Thank you, Eugene. I'm Mark Bartson, Chief of the Technical Operations Section, and one of the functions of my group is to oversee the Water Treatment Device Certification Program. And our next two speakers, I'd really like to acknowledge their coming out here today. We feel it's really important to have them here. We have a speaker from both NSF and from WQA, who are independent certification organizations that we look to for testing data, for development of standards, and their role in working with manufacturers to not only make sure devices meet standards, but that what goes on in the factory does not in any way compromise the ability of the functioning of these devices. So there's kind of two aspects, well, several aspects to the certification of these water treatment devices. First of all, the standards themselves, the testing results, and then what goes on at the manufacturing level. And both of these organizations work in all aspects of that. And we've had our water treatment device program for about 25 years now, and it's evolved from the industry has evolved into a fairly mature industry where they can squeeze more and more into a small box at a lower price point, and they can do more and more. And now with the challenges of people looking to these devices to meet standards, it's sort of at a new level. So I'd like to introduce Mike Blumenstein and Amanda Fisher, our next two presenters, and they'll tell about their programs and how it relates to the water treatment device world.
So Mike, do you want it down here or up higher? It's your choice. Okay.
Good morning. Thank you for having me. Thanks to CDPH. I'm going to talk first about the standards development and the standards administration process that NSF uses for the drinking water treatment unit standards. Then Amanda from WQA is going to go into detail about the testing that's required and specifically touching on the nitrate testing requirements for ROs under Standard 58. First of all, NSF International is an independent not-for-profit organization. We are non-governmental. We work with many different governmental organizations, including California and the CDPH, but we are not a governmental organization. Just wanted to point that out. We're truly independent. We work with the standards development and administration process to bring together the industry, the regulators, also the consumers. We often call the consumers the user group. NSF is a user of the NSF standards. WQA is another user of the NSF standards. Users could also be users of the products that are being certified. Coca-Cola and some restaurant, I think it's the Yum Brands group. They tend to have somebody who is often involved with our standards administration process as a user. There are the drinking water treatment unit standards, 42, 44, 53, 58. There also are the 60 and 61 standards for drinking water treatment chemicals and distribution system components. Any faucet is a mechanical plumbing device certified under 61, and then we also have our standard 14 for piping components. NSF is accredited by ANSI, the American National Standards Institute, as a standards developer. Our standards maintenance program, development program is all audited and accredited by ANSI. And these standards that we're talking about being ANSI standards are American national standards. It's not really the government, President Obama doesn't declare them American national standards, but ANSI does, and as ANSI being their own not-for-profit independent institute, it attributes special significance to these standards, and so a different organization can't come along and create the same, kind of recreate or create slightly different standards that cover the same topics and call them American national standards. ANSI only allows one standard per type of product to be an American national standard. So again, the standards are intended to be used by all different stakeholders, certifiers, manufacturers, regulators, users. And then there's a consensus process that we have to use when we are administering these standards. So we have to bring together the regulators, the manufacturers, and the users, and they all have to be in equal numbers in what is called a joint committee. So there's a joint committee for the drinking water treatment unit standards. There's a separate joint committee that handles 60 and 61 for the treatment chemicals and the treatment system components. And these bodies are made up of equal representation of the regulators, the manufacturers, and the users. The joint committee is the voting body. Any change that is going to be implemented into a standard has to be voted and approved on by this body, and I'll talk a bit about that in a minute. They have an internet workspace now where they can vote on things and see all documents. Everything has to be shared with this body. And then they have physical meetings at NSF's offices, either on an annual or semi-annual basis. Any task group that's formed to address a new issue, such as there's a new task group for nitrate, because one of the issues with nitrates here in California is that the standard doesn't have a high enough challenge concentration to cover some of the higher nitrate concentrations that are found here in California. So we just had a first conference call a few weeks ago to address this issue and the possibility of changing the standard to allow a higher level nitrate challenge concentration for products that wish to demonstrate a reduction of, say, 300 ppb of nitrate instead of, I believe it's 100 now. So the joint committee has to form the task groups, and then the task groups are assigned to come up with new language for the standards, new test methods, anything like that. Any new test method has to be validated. So laboratories, NSF has a laboratory for our certification program. WQA has their own laboratory for their certification program. Each of these laboratories will run the new test or the revised test to make sure that it's repeatable. We all get similar results. And one of the interesting points here is ideally for these method validations, we want to test products that are going to fail so that we can all identify the failure point or identify the failure similarly. And we will work with the manufacturers to submit, let's say, RO modules that fail their internal QC and that are headed for the garbage. Instead, they will submit those for testing knowing that they're going to fail. When we talk about administration of these standards and the process for approving changes, we talk about a consensus process. Consensus means that we have to have agreement that is more than a simple majority. The consensus process requires that all views and objections are considered, and we also have to be respectful of other people's comments and you know, their approach to wanting to do things. When changes are balloted with this joint committee, all of the negative ballots have to be resolved. In order for a negative ballot to be considered, of course, one of the requirements is that a person cannot just vote no. They have to have a reason for voting no. They have to have perhaps a revised language that they would like to see, or some evidence why they're voting no and why it's an issue for them for their no vote. Then those no votes and those comments are sent back out to the group, and the group is allowed to change their vote to a no based on these new comments and this new issue raised by the person who voted no, or they're allowed to keep their vote as a yes. So that's, all these comments, all these no votes have to be adjudicated. We can't just ignore anybody. Then for final acceptance of a new language, a new test method into one of these standards, you have to have at least 50% of the group that votes and then at least 2/3 of these people who vote have to be voting affirmative. These standards are living documents. They're always being revised, updated, sometimes every year, sometimes, you know, a couple years will go by. The standards that are used less, like 62 for distillers, are updated less often. Standard 58 for ROs gets updated quite often. And these updates can happen because of changes in new technologies that we have to consider, or advances in the chemistry, advances in the regulatory requirements, to lower, like, you know, with the arsenic requirement moving down to 10 parts per billion about 10 years ago. We had to lower our pass-fail criteria for arsenic. A couple examples here are 53 for cyst reduction and 53 for lead reduction at pH 8.5. The cyst reduction change that occurred, that was maybe 15 years ago, was a big one, and that was removing the requirement just for the test. The challenge contaminant was test dust, and then they